Let us explore something that will fundamentally shift how you see your place in the cosmos. We're discovering just how small Earth really is, not compared to Jupiter or the Sun, but against the true scale of existence. By the journey's end, you'll see our planet and yourself in a completely different light. From down here, Earth seems enormous. You could spend a lifetime traveling and never see every corner. The continents stretch for thousands of miles. Oceans cover 71% of the surface. To early humans, Earth was everything, the entire universe. Earth measures 7,926 miles across at the equator. Walking around it at a steady pace would take over 3 years. The surface area spans 197 million square miles. If you spent just 1 second in each location, it would take 6 years of continuous travel to visit them all. But when we zoom out, Earth begins to shrink. The Moon orbits 238,855 miles away, roughly the distance of circling Earth's equator 9.5 times. The Moon itself measures 2,159 miles across, about 27% of Earth's diameter. Yet the distance between us equals 30 Earth diameters. Most people don't realize this. Pictures show them close together, but the reality is vast emptiness between us and our nearest neighbor. This is our first hint that space is mostly empty. The Sun dwarfs everything in our neighborhood. Its diameter spans 864,000 miles, 109 times larger than Earth. Approximately 1.3 million Earth-sized spheres could occupy the Sun's volume. Consider that for a moment. All of human history happened on a planet whose volume represents less than 1/1,000,000th of the Sun's interior. The Sun contains 99.86% of all mass in our solar system. Everything else, all planets, moons, asteroids, and comets combined, make up only 0.14%. The Sun sits 93 million miles from Earth. Light from our star takes 8 minutes and 20 seconds to reach us. If the Sun suddenly vanished, we wouldn't know for over 8 minutes, because the light telling us it's gone would still be traveling toward us. Beyond Earth lie the other worlds. Mercury, closest to the Sun, is tiny and scorched. Venus, shrouded in toxic atmosphere, maintains a surface temperature hot enough to melt lead. Mars, a cold desert, once knew flowing rivers, but lost its atmosphere when its magnetic field died. Then we reach the giants. Jupiter dominates the outer system like a king surveying its domain. With a diameter of 86,881 miles, it's 11 times wider than Earth. Jupiter's volume could swallow 1,321 Earths. This planet contains more mass than all other planets combined. Saturn follows, nearly as impressive, its rings extending tens of thousands of miles, yet remaining thinner than paper at scale. Uranus and Neptune dwell in cold darkness beyond, taking decades or centuries to complete single orbits. Beyond the planets stretches the Kuiper belt, then the Oort cloud, extending nearly 2 light-years out, almost halfway to the nearest star. In a scale model where the Sun equals a basketball, Earth would measure no larger than a peppercorn positioned 26 feet distant. Now we venture to the nearest stars, where distances become almost incomprehensible. Proxima Centauri, our closest stellar neighbor, lies 4.24 light-years away, about 25 trillion miles. That's 268,000 times farther than the Sun. Voyager 1, launched in 1977 and traveling for nearly 50 years, would still need 73,000 years to reach Proxima Centauri. At these scales, Earth doesn't just shrink, it vanishes. From Proxima Centauri looking back, you couldn't see Earth at all. Even with powerful telescopes, the Sun would be visible as a bright star, but Earth would be lost in its glare, a tiny dot, too close and too faint to detect. All the stars you can see with naked eyes belong to our galaxy, the Milky Way, a spiral galaxy containing between 100 billion and 400 billion stars. Our Sun is just one of them. The Milky Way spans 100,000 light-years across. Our Sun sits about 26,000 light-years from the galactic center, in a minor spiral arm called the Orion Spur. We're not in the middle of anything special. We are in the suburbs, in a relatively quiet region where stars aren't too densely packed. At this scale, our entire solar system becomes just a tiny point. The Sun, which seems so massive compared to Earth, is now one ordinary star among hundreds of billions, and Earth is far too small to even register. If you compressed our galaxy into a structure 100 feet across, our entire solar system would measure thinner than a human hair's width, and Earth would be far, far smaller than that, smaller than an atom in the model. The Milky Way isn't alone. About 50 galaxies, including ours, form the local group. The largest member is Andromeda, containing about 1 trillion stars, more than twice what the Milky Way has. It's 220,000 light-years across and on a collision course with us. In about 4.5 billion years, the two will merge into a single large galaxy. The local group is part of the Virgo supercluster, spanning about 110 million light-years. The Virgo supercluster contains at least 100 galaxy clusters with around 100 trillion stars total. But even this isn't the whole picture. In 2014, astronomers discovered that the Virgo supercluster is just part of an even more massive structure called Laniakea, a supercluster of superclusters containing about 100,000 galaxies spread across 520 million light years. When you map the distribution of galaxies across the universe, a pattern emerges. Galaxies cluster along filaments and walls, forming a cosmic web. Between these filaments lie vast voids, regions nearly empty of galaxies. The Sloan Great Wall stretches 1.37 billion light-years. The Hercules Corona Borealis Great Wall extends about 10 billion light-years. 73% of the observable universe's radius. These voids make up about 80% of the universe's volume. Most of space is empty. The galaxies and filaments occupy only a small fraction of the total volume. At the scale of the cosmic web, Earth doesn't just become invisible, it becomes inconceivable. The observable universe measures about 93 billion light-years in diameter. Within this volume exists an estimated 2 trillion galaxies, each containing millions to trillions of stars. The total number of stars? Roughly 200 billion trillion. Earth is one planet orbiting one star in one galaxy among 2 trillion galaxies. If you selected a random star in the observable universe, the chance of picking the Sun are 1 in 200 billion trillion. The chances of randomly selecting Earth are so small the number is effectively zero. In 1990, Voyager 1 turned its camera back toward Earth from 3.7 billion miles away and captured a photograph. Earth appeared as a tiny pale blue dot, less than a pixel in size, suspended in a beam of sunlight. Carl Sagan reflected on this image. Every human who ever lived out their entire life on that tiny speck. Every king and peasant, every hero and villain, every creator and destroyer of civilization, all our triumphs and tragedies, all our wars and peace, everything happened on that barely visible speck. This perspective should change how we see ourselves. The disagreements that divide us, the borders we fight over, the resources we compete for, all of it plays out on a stage so small that from modest distance it disappears entirely. But this doesn't make our lives meaningless. If anything, it makes them more precious. As far as we know, that pale blue dot is the only place in the universe where life exists, where consciousness has arisen, where beings like us can look out at the cosmos and wonder about their place in it. Size isn't everything. What matters is what's here. And what's here is remarkable. Life in all its diversity, consciousness capable of understanding the universe, art, music, love, joy, all the things that make existence meaningful. Think about this paradox. We're standing on a planet so small it essentially doesn't exist at cosmic scales. Yet from this vanishing point, we've managed to measure and map the entire observable universe. This is perhaps the greatest mystery. How did unconscious matter organize itself into conscious observers? How did atoms, following blind physical laws, arrange themselves into beings capable of wonder, of asking questions about their own existence? Earth might be tiny, but it has accomplished something billions upon billions of other worlds apparently have not. It has a biosphere. It has intelligence capable of technology, of art, of science. It has beings who can look up at the night sky and determine that these points of light are distant suns, that our galaxy is one among trillions, that the universe is expanding and had a beginning. This brings us to a sobering realization about responsibility. If life is rare, if consciousness is even rarer, then what happens on Earth takes on cosmic significance. We are quite possibly the universe's only way of knowing itself. Through us, matter has become aware of matter, capable of understanding the universe. Until we find evidence of life elsewhere, we must act as though Earth's biosphere, and especially its intelligent life, is precious beyond measure. Every species that goes extinct might be a loss for the entire universe. Every potential future where humans fail to survive might mean the permanent silencing of the universe's ability to comprehend itself in this corner of space. The conflicts between nations, the competitions for resources, the damage we do to ecosystems, all of this takes on different character when we remember where we are. We're not fighting over a large territory. We're fighting over different parts of a dust speck. For most of human history, we had no idea how small Earth really is. Ancient people believed Earth was the center of everything. This geocentric view made sense based on observation. The sun rises, the moon goes through phases, the stars wheel overhead. All seemed to support the idea that we were at the center. Nicolaus Copernicus challenged this in the 16th century, proposing that the sun, not Earth, was the center. Galileo provided evidence with his telescope, observing Venus's phases and Jupiter's moons. By the 18th century, heliocentrism was firmly established. But people still thought the sun might be at the center of the universe. In the early 20th century, Harlow Shapley showed that the sun was not at the center of the Milky Way. We were about 2/3 of the way out in a minor spiral arm. Then Edwin Hubble discovered galaxies beyond the Milky Way, showing the Milky Way wasn't the entire universe, just one galaxy among many. Each discovery pushed us farther from the center, making us less special in cosmic terms. Yet these discoveries haven't made life meaningless. If anything, they've made it more precious. because in all that vastness, Earth is the only place we know where life exists. Looking far ahead, about 1 billion years from now, the sun will start heating up. Earth's oceans will evaporate. The surface will become increasingly inhospitable. In about 5 billion years, the sun will expand into a red giant, likely engulfing Mercury and Venus. Earth might survive as a scorched, lifeless rock. But that's billions of years away. For now, Earth is a vibrant, living world. And there's another future to consider, the future of human exploration. If we survive and continue developing technology, we might establish colonies on Mars, on Jupiter's and Saturn's moons, perhaps even around other stars. Earth will remain important as our birthplace, but it won't be our only home. Even if we spread throughout the galaxy, the scale of the universe will remain humbling. Human civilization, no matter how far it spreads, will occupy only a tiny fraction of the cosmos. We started with Earth and zoomed out, comparing it to larger and larger structures, until we reached the observable universe itself. Earth is small, smaller than most people realize. In a scale model of the observable universe, Earth would be far smaller than an atom, smaller than anything you could possibly see or measure. But Earth is also home. Every human who's ever lived has lived here. Every thought, every emotion, every achievement, all of it happened on this small planet. And here's the remarkable part. We can understand this. We can comprehend how small we are. We can look out at the universe and grasp its scale. That's extraordinary. That's what makes us special. Size doesn't determine value. What matters is us. And what's here is something remarkable. Life, consciousness, the ability to wonder, to question, to seek understanding. The next time you look up at the night sky, remember what you've learned. The stars are part of the Milky Way, our home galaxy. Those stars are suns, many with their own planets. And our galaxy is just one of trillions scattered across an almost unimaginably vast cosmos. Earth is tiny in all that vastness, but Earth is also home, and that matters more than size ever could.